In this video, I'm going to be talking about the first stage of an attack, reconnaissance, which is when an attacker learns more about their target. We're going to be taking a closer look at scanning and popular scanning tools like nmap that would allow an attacker to probe our systems to gain more information about them. We're going to be talking about how attackers find their targets in the first place, how they find what ports are open on those targets, the services associated with those ports, in addition to the service version and some other information that an attacker can glean just from scanning. We're also going to take the opposite perspective of being a defender and see how, through monitoring the network, we can find evidence of scans taking place. In order to help with understanding the defensive side of it, I first want to bring your attention to this diagram here. This is an example network setup that pretty closely matches to what you might see in the NCAE Cyber Sandbox and also in the actual NCAE Cyber Games competition itself. The important thing to note about this setup is that there are two networks. There's this external network and there's an internal network. You, as a defender, want to monitor traffic that's taking place both on the external network and on the internal network. But how do you actually go about doing that? Well, the devices on each of these networks are connected to each other via something known as a bridge. So this shell FTP server, this external Kali VM, this team router, and this external gateway are all connected on the same bridge. Each bridge has a set of traffic that's associated with that bridge. So that means the traffic that's destined for this router, the shell FTP server, and this Kali VM, they will all be available on that same bridge, or they will all go through that same bridge. Each of these machines will then ignore traffic that is not for them and only pay attention to traffic that is addressed to or from them on that bridge. Why is this important? Well, the big takeaway here is if we wanted to monitor the traffic for any of the machines on this external network, we're going to have to pick another machine that's connected to the same bridge. So for example, if I wanted to monitor the traffic that's going to this shell FTP server, all that traffic is going to be going through this external bridge. So if I wanted to monitor that traffic, I could monitor it from this external Kali VM because it's connected to that same bridge. So if you wanted to monitor the traffic for both your external network and for this internal network, you're going to need to set up a monitoring solution or a monitoring application on one of the machines connected to each of those bridges. So for example, to monitor the traffic on this external LAN, I would set up Wireshark on this external Kali VM. Or to monitor traffic on this internal LAN, I would set up Wireshark on this internal Kali VM. When you're actually setting up this application, which in my case, I'm going to be using Wireshark because it provides a nice graphical interface that we as defenders can interact with. But when we're actually setting that up, you're going to need to select an interface that you want to capture or monitor traffic on. The interface that you need to choose is the one that connects to the bridge. So an interface is basically an outbound port of sorts that traffic can be sent to and from. And each machine has a set of interfaces that they can make use of. So one of those interfaces is going to be connected to this bridge. How do you actually figure out which interface is connected to that bridge? Well, probably the easiest way of doing it, which I'll show you later on, is by typing in IPA, finding the IP address that is associated with that network that you want to monitor, and then seeing what interface is associated or has that IP address. So for example, this external Kali VM might have ETH0, ETH1, it might have a few different interfaces. If I do IPA, maybe I notice that ETH0 has this IP address, 172.18.15.team number. And so when I'm spinning up a Wireshark to monitor the traffic on this network, I'm then going to choose that interface that had that IP address, so ETH0. Now I'm jumping over to my attacker Kali machine, and it's time to start getting hands-on. One thing I want to make a quick note of is the environment that I'm playing around with here is different than the one that you have in the NCE Cyber Sandbox. The reason for this is I wanted to showcase some attacks on services that are not present in the Cyber Sandbox, but that might be present in the NCE Cyber Games competition. However, for the scans shown in this video, and also for any services that are available to you in the NCE Cyber Sandbox, you can perform each of these steps on the Kali that you're given access to in the Cyber Sandbox as well. The first thing I'm going to do is show you what I was just talking about in the network diagram, which is spinning up Wireshark to monitor the network. So if you wanted to monitor your network, you would pick a Kali that's connected to the network that you want to monitor. You would go here to Applications, type in Wireshark, and you'll see Wireshark pop up, and you can click on that. And the first thing you'll need to do is select the interface that you want to capture traffic on. So to figure that out, I'm going to go back to my terminal. I'm going to type in IPA, and I'm going to find my IP address, which in this case is 10.0.0.12. You'll see that the interface associated with that IP address is ETH1. So when I'm in Wireshark, I'm going to go here and I'm going to double click ETH1 to capture traffic over interface ETH1. If you weren't entirely sure which interface you want to capture traffic on, you can always select any, and this will capture traffic on every interface that's present on your machine. The reason I like to focus on the interface that I'm specifically wanting to capture traffic on is so then we don't have any additional traffic happening on other interfaces that's interfering or getting in the way and making it harder for us to see the traffic that actually matters. Anyway, I'm going to select ETH1. You'll notice that there's no traffic going on right now, but I'm going to leave this running, and as we perform our scans from the attacker's perspective, you'll see traffic pop up. Then we'll be able to go and take a look at this and see what that traffic actually looks like. Going back to my terminal, let's quickly talk about how an attacker goes about learning about their target. So the first thing an attacker needs to determine is what machines they're going to be attacking. An attacker might be given a network range, but they don't necessarily know what machines are present on that network. So how do they actually figure out what machines are present? Well, the first way of doing that is through a ping scan, sometimes called a ping sweep. So remember that with ping, we can see if a machine is accessible on the network. So for example, I have IP address 10.0.0.12. So if I were to ping 10.0.0.12 to see if that's accessible, I do in fact get replies back because my machine is accessible on the network. I'm going to hit Control-C to stop that. If I, however, choose a machine that is not on the network, so for example, if I try to ping 10.0.0.111, you'll notice that it hangs, and then eventually we're going to get a destination host unreachable message. And that's because 10.0.0.111 is not actually present on the network. So using this information, we can actually scan a range of IP addresses from 10.0.0.1 all the way up to, let's say, 10.0.0.254. And if we get replies, we know that that machine is present on the network, versus if we get something like destination host unreachable, we know that that machine is not present on the network. Probably. We'll talk about that a little bit later. Really quickly, I'm just going to ping a machine that I know exists on my network, And then we'll take a look at what that ping scan actually looks like in Wireshark. So if I do ping 10.0.0.11, I'm doing this with prior knowledge, knowing that 10.0.0.11 is an existing machine. And I run that. I'm going to let it run a few times here, and then I'm going to Control-C to exit. Now I'm going to go back to Wireshark and show you what that ping would look like from a defender's perspective as somebody who's monitoring the network. You'll notice that for the pings that failed, we have this ARP. So I'm not going to talk about what ARP is right now. We'll get into that more a little bit later. But for all the pings that failed, we have this ARP who has 10.0.0.111, and then it seems that nobody replies to that. So that's what a failed ping looks like. However, for a ping that actually does work, we have this ICMP traffic that gets generated. So as you can see, for each request that came from our attacker machine to the destination, we received a reply from the destination back to our attacking machine. And because we received this reply after issuing that request, we know that that machine is pingable, and therefore it exists on the network. For our next example, I'm just going to stop this packet capture by clicking on this red square in the upper left, and then I'm going to restart it by clicking this fin right here. And that's going to ask me if I want to save the data. So I can actually save the traffic that I captured to a file, and then I can open it in Wireshark at a later time if you wanted to do further analysis. However, for the sake of this example, I don't care to save this traffic. I'm just going to click continue without saving. Okay, let's talk about some of the shortcomings with ping. The problem with ping is it relies on that ICMP, like you saw before, that ICMP request and response, right? But what a defender could do, so let's say I know that attackers are using ping to see if my machines are accessible. I can just use a firewall to filter ping requests. So if an attacker were to ping my machine would not respond. So jumping back to the attacking side of things, as an attacker, knowing that a defender can do that, we know that ping isn't necessarily the best way to figure out a machine, whether or not a machine is actually accessible. So we need another way of doing that. And that's what brings me to ARP. So what is ARP? ARP stands for Address Resolution Protocol, and it's how a machine maps an IP address to a hardware or MAC address. What does that mean? Well, when two machines on the same network communicate with each other, they actually use their hardware addresses, also known as their MAC addresses. However, to distinguish different machines within a network, we use IP addresses. And hardware addresses are unique to every machine that's out there. It's baked directly into the machine's hardware. However, IP addresses are unique to each device on a network, but they could be the same between different networks. So this 10.0.0.0 network that exists on my Kali machine, somebody else could be using it somewhere else. And so the IP addresses there would be the same, but within the network here, 10.0.0.0, no IP addresses will overlap. Anyway, point is, when we're picking our target, we're going to be using IP addresses to distinguish that target from other machines on the same network. When those machines are communicating between each other, they're actually going to be using MAC addresses. So how does a machine figure out what MAC address is associated with a specific IP address? Well, this is where ARP comes in. What my machine, let's say it wants to communicate with somebody else, what it will do is it will reach out and say, hey, who has this IP address? And then the machine that actually has that IP address will respond and say, oh, I have that IP address, and my MAC address is this. This is necessary fundamentally for two computers or two machines to communicate between each other on a network. and therefore there's nothing a defender could do to block that traffic or that communication from taking place. Knowing that as an attacker, we can actually do something that we did with ping, but use ARP instead. So we can use ARP and say, hey, who has IP address 10.0.0.11, for example, and then if we receive a reply, we know that 10.0.0.11 exists on the network. If we don't receive a reply, we know that 10.0.0.11 doesn't exist. And we can do that with all the IPs in a given range. Similar to how we would do it, I suppose, with ping. So in order to do that on Kali, we could use a tool like ARPScan. I already have the command written out because I already ran it before, but if you were running it for the first time, you would not see that pop up. And I'm not going to go over all the options that you have with ARPScan. If you wanted to look into them, you can always use ARPScan-H. I'll look at the help screen and that'll give you all the options. But the ones I'm going to be using in this scan are -L, which is going to tell it to scan the entire network range. So from 10.0.0.1 to 10.0.0.254 in my case. Then I'm going to use I to specify the interface. And then for the interface, I'm going to use the same interface that contains the machine that I'm going to be targeting, and also the same interface that I'm monitoring, which in this case is ETH1. It does warn me that I need a super user or root permissions to run this scan, so I actually have to prefix this with sudo. If you are running Kali as the root user, so if you're actually root at Kali rather than Kali, you don't have to prefix this with sudo because you already are root, but because I'm running this as the Kali user and not the root user, I have to prefix this with sudo. Okay, if I run this, and I entered my password wrong, of course, but hopefully I'll enter it correctly. There we go. Now we see all the different machines that are on the network. And this includes machines that maybe aren't reachable using ping. If I now go back to Wireshark to view that ARP scan that we just did, you'll see that similarly to the ping scan, everything starts with an ARP request. And for machines that are not present on the network, like for example 10.0.0.19, you'll notice that there's no reply associated with that request. However, for machines that are on the network, like 10.0.0.1, for example, you can see we have this reply that says, oh, 10.0.0.1 is at, and then the MAC address associated with IP 10.0.0.1. So as defenders, if we see a lot of ARP requests for consecutive IPs that are all close to each other, then that's a pretty good indicator that somebody is performing an ARP scan to identify what machines are available on our network. So as a defender, if I wanted to look for an ARP scan, and let's say there was a lot more traffic that was generated other than just this ARP, I could actually filter by ARP by going here to this display filter box, typing in ARP, pressing enter, and then that would display only the ARP traffic that's happening on my network. From there, if I see something like 37, 38, 39, 40, 41, a lot of consecutive IPs, it's very likely that an attacker is trying to map my network and figure out what machines are available on my network. This ping scan and ARP scan that we previously looked at both fall under a class of scans called host discovery. They're called host discovery because they allow an attacker to determine what hosts or machines are present in a network range. Now let's take a look at one of the most popular scanning tools that is used in the real world. This tool is called Network Mapper, or nmap for short. I can access nmap's help screen by typing in nmap-h. Looking at the help screen, you can see all the different options that nmap has. I'm certainly not going to be going over all of them in this video, but I'm just going to show you the ones that I think are most relevant. Nmap has its own host discovery scan that it calls a ping scan. However, I want to caution you that this ping scan of sorts isn't really a ping scan like the one we were looking at before, in that it doesn't actually use ICMP echo or ping to figure out whether hosts are up. It actually uses a combination of various techniques, including that ARP scan that we looked at, and then some additional probing of the targets to try to get rid of false positives. I'm not really going to be showing that in detail, although I will go over how to perform that scan. But as a defender, you could find it the same way that you would find that ARP scan, just by looking at the ARP traffic and seeing if there are a lot of requests being made in a short time frame. Anyway, to run an nmap host discovery scan, I'll say nmap-sn, and then provide the network that I want to scan. I can actually write this network or this range of IP addresses in a couple different ways. The first way I can write it is in CIDR notation. So looking at this here, 10.0.0.0 is the network I want to scan, and then /24 is the network range in CIDR notation. So this basically tells it to scan 10.0.0.1 all the way up to 10.0.0.254 and try to figure out what machines are actually available. If CIDR notation confuses you, if you're not used to seeing that 24, you can also directly specify it by saying 1-254. So the dash in this case tells it to start at 10.0.0.1 and work its way all the way up to 10.0.0.254. So if I run this scan, just like with the other scans that we were previously looking at, we eventually get some data in return, and that has identified my router 10.0.0.1, my Kali machine, which is currently sitting on 10.0.0.12, the target that I'm attacking on 10.0.0.11, and another machine on 10.0.0.2. And going back to Wireshark really quickly, just to show you this again, this generated that same ARP traffic that the ARP scan that we looked at before generated. So if you wanted to catch an attacker doing host discovery in nmap, looking at that ARP traffic is, again, a good way to go.